Good morning, boys and girls. Welcome to our math class. Today we're going to learn about equivalent fractions. Now, equivalent fractions are also called equal fractions. And in this particular page, this is page 199, you will apply the concept of multiplication to make equivalent fractions with larger terms. I hope you enjoyed the Khan Academy video I sent you, the one where it explained what equivalent fractions are. So in this page, I will teach you how to make equivalent fractions with larger terms. So how do you make equivalent fractions with larger terms? It's very easy. You have to multiply the numerator and the denominator by the same factor. But before we move deeper into this um, lesson, I want us to look at number one first because you have to answer this. So it says, write the answers. What are you going to do? You have to read, let's say letter A, and then simply follow what it asks of you or what it tells you to do. Follow the instructions of it. So if it tells you color one half of the first circle blue, then you have to color half of this first circle blue. And then the second circle, you have to color 2/4. Okay? And then answer the question. And the questions are answerable by either a yes or a no. So that's how simple it is. So let's take a look at number two. Okay? Color the circles to show the equivalent fractions. Write the correct numerator. So if you notice, you have five circles. Okay? Cut or let's say these are pizzas, it's sliced into different equal parts. So we have here one half, and then here the numerator is missing. The denominator is given 4, and it goes the same for the rest of the fractions. The numerators are missing, and only the denominators are given. So 2, 4, 6, 8, 10. So the denominator shows you into how many equal parts your pizza was sliced. So here the denominator is 2. So your pizza was sliced in 2 equal parts. Second one, your denominator is 4. So your pizza was divided in 4 equal parts. Here, 6, and so on and so forth. Okay. So here in the first circle, it's possible for you to color, okay, because the numerator is given. The numerator tells you how many parts are used. Let's say here, how many parts are used out of the 2 equal slices. Okay, so here in one half, 1 out of 2 is used or was used. So you have to color that. Okay, let me just change my annotation. So you have to color 1 out of the 2 parts. Okay, let me just make that fast. There you go. I made it easier and faster. So here I have 1, 2, 3, 4 equal pieces. So imagine again that this is your pizza. So if I want to eat the same amount of pizza as shown here in your first circle, okay, how many of these 4 equal pieces would I have to eat so that I would have the same amount like this? So I want you to pause and think. Well, I would eat this part and this part. So to have this size, so I have to eat 2 pieces. So let us color that. Oh, by the way, I have to eat 2 pieces. So let me just write the number here. Okay, so that means I have to eat 1, 2 slices, 2 of this, to end up eating the same amount as the first pizza. So let me just finish coloring that. Tanan, I finish it. So you have to do the same thing for the next one. Okay, now let's move on to number 3. Oops, let me just clear that. Okay, number 3 says multiply the numerator and the denominator by the same factor to make equal fractions. So before I teach you how to make equivalent fractions with larger, gosh, I forgot what I'm going to say. I lost my chain of thought. With larger terms, okay? I'm so sorry. I'm so sorry, boys and girls, okay? Now I want you to take a note. I want to show you something. Now I want you to look at the screen, okay? This is a very important rule. Equivalent fractions can only be made by multiplying or dividing. That means you cannot make equivalent fractions using addition or subtraction. Okay? Now, if you're making an equivalent fraction with larger term, you use multiply. And when you want to make an equivalent fraction of a smaller term or with smaller term, you use division. And whatever I do to the numerator, which is the top number, I've got to do to the denominator, which is the bottom number. So please try to remember this rule. It is very important, especially in equivalent fractions. Now let's go back to page 199. So if you want to make an equivalent fraction with the larger term, you have to think of a factor, okay? A factor is a number you multiply with another factor, okay, to get a product. So when we speak of factor, it can actually be any number of your choice. It can be 2, 3, start with 2, please. 2, 3, or it can go to an even bigger number, but I want you to focus right now on smaller number. So in this particular seat work, the factors are already given or written for you. And notice that when you multiplied whatever factor you use to multiply the numerator, you use the same number, okay, to multiply the denominator. So in this case, you have 3 for your factor. So you multiply the numerator 1 times 3. The answer is 3. Okay. Oops, it's way too big. It's okay. Over 2 times 3 is 6. So that means 1/2 is equal to 3/6, or 1/2 is an equivalent fraction of 3/6, or 1/2 is equal to 3/6, or 1/2 and 3/6 are equivalent fractions. I don't know what's with me today. Okay, next one, letter B, 3/5. Okay, we need an equivalent fraction, a larger one. So here, the factor is 2. So whatever you do to the numerator, you ought to do it in the denominator. So if you multiply the numerator by 2, you multiply the denominator by 5. So let's go ahead. 3 times 2 is 6. Better. Fraction bar. 5 times 2 is 10. So, okay. 3/5 and 6/10 are equivalent fractions. Okay, so let's move to page 200. I can't believe we're already in page 200. So for page 200, you have a number 4, story problems, and you have to write your answer here in the workspace. Letter number 5, you have to solve the measurement equations, A and B. Number 6, follow the signs. Be very careful with your signs. 7, divide and check. Number 8, fill in the missing term. Now we have here the brain booster, and this is something new. Okay, this is what you call the Fibonacci sequence. Okay, I don't know if you have heard of a Fibonacci sequence. Now, Fibonacci is an Italian mathematician. Okay, he was the most famous mathematician of his time. And so he came up with a fun pattern. And this is what you call the Fibonacci sequence. It is something like this 1, 2, 3, 5, 8, and 13. Now, each of these number is what you call a Fibonacci number. So study it to see if you can find the pattern. I want you to look at it and try to see if you can tell me the pattern. Have you thought of it? You think you figured it out? If you have figured it out, then should I even tell you the answer? Okay, I think I will. Okay, so you have here 1, 2, 3, 5, 8, and 13. Now you might wonder, Mrs. Maya, okay, you started with 1. Why is this 2? Why is this 3? How did I get 5? How did you get 8? How did you get 13? Okay, so in the Fibonacci sequence, okay, each number is the sum of the two preceding numbers. When you say precede, that means before. So I want you to look at 1 and 2. If you add 1 and 2, the answer is 3. So the two numbers preceding 3 or the two numbers before 3, if you add that, okay, 3 would be the sum. I hope I make sense. Now let's take a look at 5. So 5 is the sum of the two preceding numbers. Again, 5 is the sum of the two numbers that preceded it. Or 2 plus 3 is 5. Now, look at 8. 8, look at the two preceding numbers, add that, 3 plus 5 is 8. And then look at 13. If you look at the two numbers that preceded, you add it, 5 plus 8 is 13. Now, I hope you got it. Isn't that fun? Because I really enjoyed it. Okay, God bless you and let the peace of Christ reign in your heart. Bye.